with the combine like terms with distributive property assignment. Simplify each expression. There is no more evil word in mathematics than simplify, because it's never simple, right? But the distributive property is one of the fundamental properties of all mathematics. And if you aren't comfortable with it, this exercise here will help to ameliorate that. And ameliorate is one of those big SAT words that means make it better, make it easier, fix it. So what I like to do is use what we call distribution arrows. And I do this even now, even though I know what to do, I still draw these arrows because I get tired, I get distracted, and this helps me. So starting with number 1, we're going to put these distribution arrows to show that we're going to multiply this -4 by each of the terms inside the parentheses. So I'm going to draw an arrow from the -4 to the 1. That's a multiplication. -4 times 1. And then I'm going to draw another distribution arrow to the 4a, -4 times 4a. And I'm going to show exactly what is happening right now. So what we're doing, let's put an equal sign here, okay, is we're saying -4 times 1, and I'm going to put those in parentheses to group them so you understand. And then this plus symbol stays plus, and then -4 times 4a, -4 times 4a. Okay, and I'm going to put that inside parentheses. I really want to see this step. You're just starting out with distribution. I want to see this step. That's an intermediate step that I really want to see. Okay. So now we can multiply out. -4 times 1 is going to be -4. We can drop the parentheses now, -4. And then let's think about this for a minute. -4 times 4a. So the a just comes along for the ride. We just multiply -4 times 4. That's -16. So -4 times 4a is -16a. So we have -4, and then if it's okay with you, I'm going to just say minus 16a. Okay, and that's it. We're going to put that in a box. And we're going to move on to number 2. 5 times a plus 9. Well, so we're going to multiply 5 times a, and we're going to multiply 5 times 9, and we're going to add those together. Okay. So I draw these distribution arrows to show just what I'm about to do. And then we do it. So let's put an equal sign. We have 5 times a. All right, that gets a parentheses around it. Plus 5 times 9. And that gets a parentheses around it. Okay, and now we're going to drop the parentheses. 5 times a is just 5a. So 5a. 5 times 9 is 45. So we just put plus 45. And that's it. Just put it in a box. Okay. All right, we're done with number 2. Moving on to number 3. Oh boy, a squared symbol. Well, let's see what happens. Okay. So first of all, let's just put this 9r squared and just kind of forget about it for a second. And let's focus on distributing 6r to negative r and 6r to 9. Now there's something I need to teach you right now. So pay close attention to this. This is called the product rule. Product rule for exponents or of exponents. And you have to know this rule in order to do this problem, okay? This is very, very important. If I have some value, and we call this a base, okay? If I have a to the m, so that's just some exponent, and I multiply that by some value a, again, a is the base, a to the n. So notice this, it's very important. The bases have to be the same for this to work. That is equivalent to a raised to the power of m plus n. Okay? Another way of saying this is when the bases are the same, sorry, I gotta deal with the left hand. When the bases are the same, add the exponents. Okay? Add the exponents. Now, why did I just show all that? First of all, let me put this in a box because this is really important. This is one of those one of those big rules that you got to learn. It'll be all over the STAR test, and it comes up a billion times. So learn it. Okay, product rule of exponents. Bases are the same, add the exponents. Really simple. Okay, so let's go back to the problem. Look right here. I have R and R. Now, what are the exponents that I'm adding? Because I don't see any exponents. Okay, well, I want to make a little note down here, okay? A equals A to the power of 1. Therefore, okay, those 3 dots mean therefore, R equals R to the power of 1. Okay? Well, let's go back to our problem now that we know that, and let's rewrite it. So first, I'm going to put an equal sign over here, and I'm going to give myself some space and write the 9r squared. Remember, we don't care about that right now. 9r squared plus, and now I'm going to write 6r, but I'm going to go ahead and give myself that exponent of 1 times negative r, and I'm going to go ahead and give that letter the exponent of 1 plus 9. And now I'm going to rewrite those distribution arrows, this time in blue, so they don't contrast with, so that they contrast with the red. Okay, so now I think we can proceed. We have the 9r squared still hanging out by itself. Plus, and now I've got, let's put in parentheses here, 6r to the first power times negative r to the first power plus, and here because the 9 doesn't have any like r's, you can just write 6r times 9. 6r times 9. Okay. All right, well, let's keep going. So that equals 9r squared. And now let's think about this for a minute. Forget about that negative symbol, okay? That doesn't matter. 1 plus, these are the bases, by the way. R and R, those are bases. The bases are the same, so we add the exponents. 1 plus 1 is 2. And I think I should probably write down here, negative R is equal to negative 1 times R. All right, you got to start to see that. So moving back up to the problem, we got 9r squared plus, and then in here, I'm going to have 6 times negative 1, since there's a 1 right in there. That's a negative 1 in front of the R. I'll have 6 times negative 1, that's negative 6. And then r raised to the power of 1 plus 1. Okay, plus. And now here I have 6r times 9. Well, 6 times 9 is 54, so 6r times 9 is 54r. So I'm just going to write 54r. Okay, we're moving right along. 9r squared still hanging out alone, but not for long. Okay, now 1 plus 1 is 2, so I can write, instead of plus and then all these parentheses, I can just write 9r squared minus 6r squared. Plus 54r. Okay. I should add here that you can't play the exponent game when it's addition. This has to be multiplication. Okay. There's a similar rule for division. You can probably guess what it is. If multiplication causes you to add the exponents, division would cause you to subtract the exponents. But addition and subtraction do not apply. So there's here we can work with this because r squared and r squared are the same. You can kind of think of it like a common denominator. I'm allowed to subtract 6 from 9. So 9r squared, think about it like this. 9 blob minus 6 blob is 3 blob. And blob is r squared. So, all right, equals 3 r squared plus 54 r. Okay. Now, I was always taught to factor out the greatest common factor. So this is an acceptable answer, but what I was taught to do, and I'll put this in a, anyway, let me show you what I was taught to do. I was taught to say, well, 54 is divisible by 3, and so is 3. So I was taught to divide out the 3, okay? And then I was also taught to divide out, I can see I can divide out 1r, right? So that's an acceptable answer right there. But I could also have written it like this. 3r, open parentheses, r plus, and then 54 divided by 3. Well, 3 goes into 5 one time. With 2 as a remainder, so 24. 3 goes into 24 8 times. I've completely divided this r out, put it over here. So these are both equivalent. If you distributed this back in, you'd get 3r squared plus 54r. So I don't know what they want you to do. This is fully reduced. This is the one that I learned, but I'm not sure what they want you to do. So I'll just put them both here. Both are acceptable answers. All right, well, that took a long time because we had to go over the rule, but now you know the rule, okay? And I actually did the quotient rule for exponents, the division rule, here when I divided out those r's, but let's just move on to number 4. All right, number 4, doesn't look like we're going to have any weird squared problems here. We're just going to distribute the 9 to the 1 and to the negative 5b. Okay. So here I've got 9 times 1 plus, notice I just invented a plus symbol, plus 9 times negative 5b. And then don't forget about the plus 3. Okay. All right, let's keep going. 9 times 1 is 9. 9 times negative 5b, well, 9 times 5 is 45, so 9 times negative 5 is negative 45, so 9 times negative 5b is negative 45b, so I'll just put minus 45b plus 3. And so now it's going to help us to move some things around here, right? Because this b means I can't add or subtract the 3 and the 9 to it, but the 9 and the 3 can still be added. So you're allowed to do this. Just lead with the negative 45b. And then you can say plus 9 plus 3. Like that. You're allowed to reorder the problem as long as you keep the signs together, okay? So as long as we have that. So now I've got this equals negative 45b plus 12. And please notice that that is equivalent to 12 minus 45b. Both are the same. Once again, I was taught to continue to reduce. So like, what can I pull out of the 45 and the 12? Well, 9 times 5 is 45. 3 times 3 times 5. 12 is 3 times 4. So I could pull a 3 out of both. Okay. So I'll show you what I'm doing here. I'm dividing out a 3. Now I'm going to leave that. That's a fine answer. Okay. But you could also write it like this. 3, and then open parentheses. 12 divided by 3 is 4. Minus 9b. Now, I have no idea what they're really looking for, all right? But I'll tell you this. These are all, these are all fine answers. I don't know what, I was always taught this one, all right, to fully simplify it down. But who knows what they're teaching these days? And honestly, it depends on the purpose. Like, what is your goal? I'm telling you right now, this is the way to go, folks. But nevertheless, I'll accept all those answers. Moving on to number 5. Oh boy. Okay, so here we are going to have a product rule thing. Okay, see, x to the first times 2x. Just want to help you guys out here. I've got x to the first times 2x to the first. Okay, and that's going to equal 2x to the 1 plus 1, which is going to equal 2x squared. So when we get to that part, you won't be super confused, okay? We'll just put that in a little bracket. All right, moving on. So here we are with number 5. We're going to distribute the 2 to the x and 2 to the negative 7. And then you can go about this in a few ways. Let me actually modify my thing here. How about negative x to the first times 2x equals negative 2x to the 1 plus 1 is negative 2x squared. And so that helps me capture that negative symbol. So I'm actually going to put that negative x in a parentheses, all its own, okay? And that means that in the middle here, there's a plus sign, okay? So let me rewrite this. We have 2 times x plus 2 times negative 7 plus negative x times 2x plus negative x times 4. And I'm going to run out of room, so I'll have to write down here negative x times 4. Okay? So 2 times x is just 2x, so we can write 2x. And then 2 times negative 7, that's minus 14. Negative, so just put minus 14 here. And then we already talked about this. Negative x times 2x. That's this, negative 2x squared. Okay, so we'll put minus 2x squared. And then we have negative x times 4, so minus 4x. Minus 4x. Okay, so there are some like terms here. The 2x and the negative 4x can go together. All right, well, what is 2 minus 4? It's negative 2. So 2x minus 4x, or 2 blob minus 4 blob, is negative 2 blob, or negative 2x in this case. So I've got negative 2x minus 14 minus 2x squared. Okay, you're almost right. So I'll accept that answer, but the correct answer is to order by exponent. So first we put what x squared, so we would write negative 2x squared, and then we would go with x, because that's x to the first, so we have x to the second, x to the first, and then we have this number with no letter at all, and that's called a constant, and that always goes at the end. So you would go negative 2x squared minus 2x minus 14. That's the proper way to write this. So I'm going to write it the proper way. Negative 2x squared minus 2x minus 14. And again, that's acceptable, but there is something we can do. You could divide every term by negative 2. And that would reduce this down more. It's like factoring out the greatest common factor, only put a negative sign in front of it. So that is equivalent to, we'll put the negative 2 out front because it doesn't just disappear, it's there. And then we have inside just x squared. And now I've got negative divided by a negative is positive. So plus x. Notice that I divide negative 2 by 2. I just leave the x behind. And then negative 14 divided by negative 2 is positive 7. So plus 7. And that's, again, this is how I was taught to do it. But I'll accept all three of these since you're just now learning. But just remember, the bottom one is the right one. Okay. Again, it depends on what you're trying to do. But, I mean, in some cases, you might want to have left the negative symbol and just divided out the 2. Anyway, moving on. Number 6. Okay, so I can see here we're going to have a b times b. So that's b to the first times b to the first equals b to the 1 plus 1 is b squared. I'm going to assume that you guys got that now. So we're going to multiply negative 9 times b, negative 9 times positive 4, b times b, which is b squared, and b times 1. Okay. So this is equivalent to negative 9b plus negative 9 times 4 plus b to the first times b to the first. Those aren't 6s, those are b's, plus b times 1. Anything times 1 is itself. Okay. All right, moving on. So we have negative 9b. And then negative 9 times 4 is negative 36. So we'll just put minus 36. B times b is b squared. So plus b squared. And then b times 1 is b, so plus b. Now, notice something. We have this naked variable, right? So it actually has a 1 in front of it. That's going to help us here in a second, because negative 9b and positive 1b are common, okay? They have a common term, of b. So we can actually combine those. You say, well, what's negative 9 plus 1? Negative 9 plus 1 is negative 8. So negative 9b plus 1b is negative 8b. Okay, negative 8b. And then we have the minus 36 plus b squared. Now that's an acceptable answer, but remember we'd prefer that you put the term with the squared first, then this term. By the way, this is called the quadratic term, the linear term, and the constant term. Quadratic first, linear second, constant third. Quadratic, linear, constant. 1, 2, 3. So the preferential order would be b squared minus 8b minus 36. And notice that while I do have common factors with 8 and 36, my coefficient in front of the b squared is a 1, so there's really no way to like pull anything out. So I would take either of these two answers here. The more correct answer is the bottom one, if you're trying to be a perfectionist about it. This is the quadratic form, and this becomes very important later on in Algebra 1. So really just order by decreasing order of exponents, and you'll be fine. Okay, so we're moving on to number 7. And number 7 has very helpfully given us a bunch of fractions to work with. Yay. But nothing changed. So we're just going to multiply 3 halves by 11 halves x and 3 halves by 5 ninths. Okay? That negative 1/2 is going to come along for the ride. So we'll start out by writing negative 1/2. Okay, plus, and now we got 3 over 2 times 11 over 2. And we're going to write all that out. And the x comes along for the ride. Plus 3 over 2 times 5 over 9. Okay, so, we need to group these. And I actually see a reduction that we can do. See right here, I've got my diagonals, 3 and 9. Well, I can cancel those and divide both by 3, leaving behind a 1 and a 3. Okay, just makes the multiplication a little easier. I can't do anything here. 3 and 2 are both prime, 11 and 2 are prime, so go back, we'll write negative 1/2. Don't drop that negative. Don't forget about the negative 1/2. It's very easy to do if you're not writing everything out like this. Plus Now let's go ahead and multiply across the top and across the bottom. Well, 3 times 11 is 33. Two times 2 is 4. And the x comes along for the ride. Stuck right there, okay? All right, and now we're going to do this one, plus. So our simplification made everything easier. 1 times 5 is 5. Over 2 times 3 is 6. Okay, so now all I have to do is to find the lowest or the least common multiple between 2, 4, and 6, which is 12. So I need to multiply negative 1/2 by 6/6. 33/4 needs to be multiplied by 3/3. And 5/6 is 2/2. 2 over 2. Okay. So let's go ahead and that done. We have negative. Well, I'm looking here, and we want the common denominator. So I've got negative 6 over 12 plus 3 times 33, that's going to be 99, right? 99 over 12 x plus 10 over 12. So 5 times 2 over 6 times 2. Okay. Now, because I've got the common denominator, I can actually rewrite this as negative 6 plus 99x plus 10 all over 12. Okay? And I'm going to break this up again. So now, the negative 6 and the 10, those are common with one another. So we just do 10 minus 6 gives us 4. So this is equal to 99x plus 4 over 12. That's one way to leave it. That's, I mean, technically correct. But what we should probably do now is split this fraction back up. Okay? Basically, I'm going to give a 12 denominator to the 99x and a 12 denominator to the 4. Right? So I got 99x, okay, like 99/12 x plus 4 over 12. And maybe I can reduce those fractions. I can divide this top and the bottom by 3. And that'll give me 33 over 4. And then I can cancel the 4 and the 12 and leave behind a 1 and a 3. So my final reduced fraction, fractions plural, would be 33 over 4 x plus 1/3. And I don't know, what do they want? I don't know. All of these are correct. if I were betting money, I would say that one was the right way to go, but that's old school, so who knows. All right, here we are with number 8. Number 8. So I'm going to go ahead and put a little bracket around the -3/2 so that we know we're distributing the negative sign with the 3/2. And that'll be times m, and then times 4/3, okay? The 19/6, it can just hang out for a second. All right, let's get to work. So we got 19/6. I'm going to put a plus sign. Okay, that kind of separates that away. And now -3/2 times m is just -3/2m. So I've got -3/2 times m plus -3/2 times 4/3. -3/2 times 4/3. Okay. Now let's just keep going. So here we've got 19/6 minus 3/2m. And then we better look, we can cancel some stuff here. I can cancel those 3's and leave behind 1's. And I can cancel the 4 and the 2 and leave behind a 1 where the 2 was and a 2 where the 4 was. So that's going to be minus, because of that negative sign right there. 1 times 2 is 2. And then 1 times 1 is 1. Okay. So now to continue, I'm going to have to find common denominator. So least common multiple between 6, 2, and 1 is 6. I don't have to do anything to the first fraction. Second fraction, I'm going to multiply by 3/3. And then here I'm going to multiply by 6/6. I see, so in that case it wasn't a good idea to simplify it, but whatever. We got 19/6 unchanged. Minus 3 times 3 is 9. Over 6m minus 12/6. Okay. So we can combine like terms here and here. 19 minus 12 is 7. So that gives me 7/6 minus 9/6 m. But I can reduce the 9 and the 6 to 3/2. So this gives me, I mean, there's two ways to write this, right? You could have either written it as -9m plus 7 all over 6, or I think the better way is to leave it broken up like this and write it as, what would that be here? -3/2m plus 7/6. See, I would have been taught that that's the fully reduced fraction. But again, they're all good to go. All three of these are acceptable answers. Okay. All righty. Okay, this one looks a little confusing, but what's happening here is you're actually distributing a -1. See, there's a -1 here, and you can kind of bracket that off, and that's what you're distributing. -1 times both of those things. So that -3/4 n is just sitting out to the left, hanging out, chilling. So what have we got here? We got -3/4 n plus, and then we have -1 times -6/5n. Okay, plus -1 times 4/3. Okay, and so let's group all this stuff. So we'll group this by itself, this by itself, and this by itself. It's almost like 3 separate problems. So nothing's happening here. Just forget that for a second. Remember, you can write this over 1. Okay, so that'll help. Let's deal with these. We're really just going to multiply across the top and across the bottom because there's no reduction or anything like that. You're really just changing the sign when you multiply by -1 or divide by -1. You're just changing the sign. So a negative times a negative is a positive. So this is just going to be 6/5n. And this is going to be, it was positive, now it's going to be -4/3. So let's go back here, get rid of all these parentheses here. We got -3/4n. And then, like we said, this is going to become positive 6/5 n, so plus 6/5 n. And then we said we were going to turn this 4/3 negative, so minus 4/3. Okay, well, we need to find a common denominator between the n's, 4 and 5, so that's going to be 20. So we'll multiply this -3/4 by 5/5 and the 6/5 by 4/4. Okay, and then this guy can just hang out, this -4/3. We'll see if we need him in a minute. That'll give me -15 over 20 n plus 4 times 6 is 24 over 20 n minus 4/3. Okay, so now I can say, all right, what's -15n plus 24n? Well, what's 24 minus 15? Who knows? Let's subtract 15 from 24. It's 9. And so I could write this like we are working with those two. 24 minus 15 is 9. So 24 twentieths in minus 15 twentieths in is 9 twentieths in. So I'll write 9 twentieths in minus 4/3. Okay. And that's how I would leave it. I don't know if CUDA would want it some other way, but to me that looks reduced. And on to the final problem, number 10. Okay. Oh, look, we're going to finally distribute a whole number. So 7 times x and 7 times negative 6/7. There's going to be a trick in there. And then subtract 1/3 x, combine like terms, and we're all done. So we'll multiply the 7 times the x and the 7 times the negative 6/7. And let's see how it goes. Okay. We're going to put a mark there. Okay, here we go. So I have 7 times x plus 7 over 1. I'm taking the liberty of writing this 7 as 7 over 1 times negative 6 over 7. And I think you'll see why. Okay, look. Okay, they cancel. And then we have minus 1/3 x. Okay, so I'm thinking ahead. I know I'm going to be working with the 7x and the negative 1/3 x, so I might as well make 7 into something with a denominator of 3. And so I could just think of this as 7 over 1 and multiply it by 3/3. And I've got 21/3 x. I'm going to go ahead and move this negative 1/3 x right here, just so you see what I'm talking about. Negative 1/3 x. And now I think you see how those are going to group together because they got a common denominator, see? And they share the x, so they're common terms. But here's the fun part, plus. Well, I can cancel those 7s down to 1s. And 1 times negative 6 is negative 6, and 1 times 1 is 1. So this is just plus negative 6. In other words, minus 6. Well, 21/3 minus 1/3 is 20/3. So 21/3 x minus 1/3 x is 20 over 3x. So this equals 20/3 x minus 6. And that, my friends, is that. That concludes this tutorial on the combining like terms with the distributed property. And thank you so much for watching.